Welcome to Securing EC2 Resources with AppGate, a step-by-step setup guide. This video is a supplement to the document, which contains all the steps, screenshots and details to fulfill this. It assumes you have seen the introductory video which explains the security challenges associated with the move to EC2. It also covers the software-defined perimeter. As a recap, AWS security groups are centered around IP addresses and not users. This results in a difficult management of adaptation to changing users and server environments. The software-defined perimeter is addressing these issues. AppGate has implemented the software-defined perimeter specification, which provides a dynamic and individualized perimeter automatically adapting to policies and users. We capture the contextual situation of the user and the system at what it should provide, and it can dynamically adjust to these changes. The AppGate architecture is built up of three components: a controller, the gateway, and a log server. The controller can be seen as the authority of the system. It's issuing tokens, and it determines, according to policies, what access rights a client will get. By client, we mean the end user. The end user is using the client over the virtual network adapter, communicating with a secure encrypted tunnel to the gateway. The gateway is the component which actually protects the resources that we would like to access, something we call also the site. The gateway has a second level of policy enforcement and will at the end decide if traffic is allowed or denied. Third and last, we have the log server, which is a central logging mechanism collecting all the events happening in the distributed system. So today we're going to set up a single resource in EC2, which we're going to protect by the AppGate system. For this example, we've chosen to have a Tomcat server. Of course, in your environment, there will be probably different servers, many servers, but for the purpose, that's good enough. We have a client which will be installed on your computer. And of course, in the EC2, we will have the controller, the gateway, and the log server. Actually, those three components will, in this case, be homed on the same instance, so to speak. So whether they are distributed or not, they can be hosted on the same instance. And that's exactly what we're going to do here. So we're going to show you what the prerequisites are. There are three simple prerequisites. And then we step through 1, 2, 3, 4. And every step here is documented. And I go through in detail so that you will be successful. So before we start, we need to make sure that we have a virtual private cloud available with a subnet. You probably have that. Otherwise, please go ahead and do that. We will need available elastic IP address. You can easily get one of these, which are needed actually for the access of the instance. And finally, we'll need a AMI role with the permission for read access to EC2. This will be needed that we can resolve names to IP addresses. So now we're going to walk through the AMI creation. So once you have chosen the AMI from the marketplace, we're going to choose the instance type. For testing purposes, the T2 medium is far good. So select this one and click next step to continue. So configuring the instance details is straightforward. In the network, choose the VPC that you have created earlier. The subnet, in my case, I've chosen the subnet 10.10.10.0/24. It's the header of the VPC. So choose the one that you have created there, and remember the actually subnet will as well be the network hosting all the protected resources. So we're going to launch the instances into it. Keep the auto-assigned public IP empty. So we're going to actually add a elastic IP in a later step. The AAM role, you should choose now here the one you created earlier, or create one now. Remember, this is the EC2 read access. The rest of the settings here you can keep as it is. We will actually choose ET0 as a device for network interface, that's fine. And subnet should be mapped now when you have chosen the above setting already. The storage looks good here. We keep it as it is. The presets all fine. So now click next for add tags. So add the tag, which names your server. I called mine here AppGate server. Just kept it simple and will easy for me to find it while managing through the console. So we can continue and click on Next to configure security group. So now we're going to create a new security group and decide what is allowed to talk to our instance. Just remember how we actually have to set up this. In the beginning, the person that will need to have access to the AppGate system is you as the administrator. And the very first thing we're going to do will be seeding the appliance, and that is done through port 22, an SSH session. We also will open the port 444, which allows us to administer the system later on a graphical user interface in the browser. We also need to have a client possible to talk to the system, and that's communication is all done over TLS on port 443. So at the moment we want just to limit the IP address that can access the instance, that be you. So we have now applied these settings here already in the security group that you can see. So we have 3 rules: TCP protocol from port 443 for the clients to talk to the system, port 444 for the graphical user interface, and port 22 for the initial seeding that we're going to do. In the drop-down menu on the source, you can simply choose My IP, which allows you to access it only from your IP and nothing else. So that looks good. So press Review and Launch now. So it looks good now. Now after clicking Launch, you will be asked to select the existing key pair or create a new key pair. We will need that initially for the seeding, so we can establish an SSH connection to the appliance. So when it's done, please launch the instance. In the Network and Security section of the AWS console, click on Elastic IP. There you will be able to actually associate an available IP to the launching instance now. As you can see in my setting here, I have chosen the instance and I'm just launching, and the private IP will just be given from the internal subnet that you attach to. After a minute or two, you can go on the EC2 dashboard and verify the instance now running properly, and as you see, all the settings have been applied and we are ready now to do the next step. Step 2 is to seed the AppGate appliance with the initial settings. We will actually access the appliance through the SSH and do the seeding via command line. Just follow here and I'll walk you through that. Go to the EC2 dashboard and click on your instance. Here we'll find the description, and in the description you see the public IP. We would like to now establish a SSH connection to that appliance so we can seed it. So copy the URL or the IP address and copy paste it into your PuTTY or SSH terminal. We're going to use SSH terminal, so let's do that. So we do SSH -I for identity file, and we have the PEM file that we got while launching the appliance. The user will be CZ, that's the default user, and of course the IP address that we'd like to add. Yep, accept the fingerprint. There we go. We're logged in on the appliance now, and we can now configure the first appliance as a controller through a menu-driven tool. So it's called CZ setup. To run that, just have to command the sudo CZ setup. Here we say that we start as a controller, so let's configure it, press enter, and give it a host name. So the host name actually reflects the IP address or the host name that has to be communicated to with. So let's add this one. We actually want to use a host name and not the IP address, so let's just make sure that we get the public host name of our Elastic IP. Either you do that through a lookup, like I do, or an online service that does the same thing. So we can actually enter here the same 35.157.62.23, and this will give us the host name. So it's a pointer, reverse host name. So we copy this and add that to the host name here. So this will automatically fill you the host name for the IP reached by the clients, which is the same because we have all these 3 sites, so to speak, from access from the same IP. So that looks fine. We need to configure network interfaces. Network is 0, that's the only one we have, and that's just fine. We make sure that IPv is enabled and that IPv6 is disabled. Everything else should be good. Static address none, that's fine. We then would like to add a DNS server. You can ignore static routes and this. So DNS servers, we just simply use the Google one. 8888, that's fine. We don't need to configure anything more from the appliance settings, but we would like to set the administrator password. So the admin user will be the user you're going to use accessing the graphical user interface with. So let's give it a password, one of your favorite passwords. Do not match, of course not. Let's try that again. That's it. So we can leave the menu now and say apply configuration. That should be it. Yes, it will take about a minute until this is ready. So as you can see now it's ready. So we try to access it from the browser. Let's open a new tab. Don't forget to put HTTPS and 444. As you can see from the information you get here, it's exactly what we want. So here is the actually verifying of the certificate, which is a self-signed certificate we can accept. Proceed to it. And now you can see that we have an instance up and running, asking for us to add the username and password. That was just what we did in the last step in the user interface. Admin and the password. So here we go. Now you have logged in and succeeded setting up the first appliance. Looking at the AppGate dashboard, we see that we have now a controller and a log server set up. There's 0 gateway, and that's because we haven't configured that yet. Let's look at the presentation for some time. The gateway, the site, and the resources. These three configurations are going to be established now. So the gateway will provide all the information regarding the tunneling so that the communication from point to point will be established. The site, in another turn, will provide all the information regarding the subnet and how these resources in that subnet will be reached. Most importantly here to mention on the site configuration is the resource name resolution. We're going to use actually the dynamic resource name resolution. So instead of using static IP addresses or host names, we're going to use name resolutions depending on tag names, etc. So these will allow us then finally to communicate with the resources we set up in the last step. So let's go and define the gateway and the site configuration. So let's go and add a new site. On the left-hand menu, you can go under Configurations, Sites, click on Sites, and then add New Site. So give it a name, for example AWS Frankfurt. Nodes, whatever you like to give for a reminder. Networking, we don't need to add this checkbox here, entitlement-based routing at the moment. We'll have subnet, so we're going to add a subnet, and the subnet is the one defined in your EC2 VPC subnet, which for our case is 10.10.10.0.24. We will then ensure that we allow SourceNet and TLS enable. TLS enable, this means that we're going to do the tunneling. That's fine, the default setting. We're going to see that we have the name resolution part here, and that's where we're actually going to make sure we allow that on this site we use the AWS resolvers. We can give it a name, AWS resolver 1. The AIM role checkbox will be checked in, because since we launched the instance with the IAM role attached to it, the instance inherited actually the access rights, so which was in our turn to use the fabric layer for querying our API querying the EC2 fabric layer for tags and resolved it to IP addresses. So by clicking here, use IAM role, we can effectively use that instead. There has been another implementation earlier, which could be created an access key for it and use the access key ID and secret access key. But this is a hassle to update and manage. So it is much more preferable to use the IAM role. The rest here can be checked as it is. So the last step here for the AWS resolve is to add the region. So click on region here and enter the compact region name. In our case, this will be EU Central 1. That is Frankfurt region that we have chosen. There is a link in the document showing you where to find these abbreviations, compact names on the AWS documentation. Now we have created our first site and should save this. So now when you have created the site, which is it's kind of the collective or the subnet we're protecting at, we have to provide the way to access it, and that's the gateway. So the gateway actually requires to have a site. And this is kind of the chicken and egg, but in our configuration it's straightforward because we have established the site configuration and will now define the tunneling configuration, which is still, as we said from the beginning, on the same appliance. So let's do that. Now it's time to configure the gateway. For that, we have actually to configure that on the appliance itself. So let's move to the configurations, appliance, and we just want to edit the current appliance. Remember, this is a single appliance. So we're going to edit this one. We have the basic settings, which we already provided through the CSAT setup menu during the seeding. We now would like to say that this appliance is actually attached on a site, so that the system will know that resources accessing in that site will go through this appliance. So we choose the site that we just created before, and make sure that these networking settings here are correct. So ET0, that's fine. We use ETHCP. We have the DNS servers that we have also provided through seeding. It's 888, that's fine. We don't need to add any particle routes, that's good. We have the capability we have to turn on, which is the gateway by itself. So let's look at this one for a moment. Down here you see the controller, gateway, and log server. So here we define on an appliance what actually kind of feature is running it. So controller and log server we have already decided to be it, but now also gateway. So let's click on gateway and make sure that this is enabled. So by checking here this box, we will enabling the gateway functionality. We don't have to do anything here with the latent weights, but we have to add a destination. So here actually, this is a repeatable information, but it's important since the appliance and the site sharing the same object. So we have to give them the same subnet here as well. And the subnet left 10 is 24. The network interface is ETH0. That should be it. So let's save this. And now we can go back to the dashboard and review that we actually have one gateway now set up. As you can see now we have an appliance with a gateway, controller, and log server. So now we actually should prepare a resource that will be put into that site, in that subnet. And for that we can simply use an example Tomcat server, which provides us with a web-based access. So let's do that. Let's go to the EC2 management console and launch a new instance. Tomcat stack, so let's select this one. Choose the general purpose T2 medium instance and click on next to configure instance details. Here we're going to choose the VPC that we are actually operating in and also the subnet where we have to put actually the instance in. So this is a subnet that is protected by the AppGate system. So the subnet is the same as the gateway attached to it. We don't have to put any public IP address here, since we don't want even to be reachable from the outside. The only way to get to this instance will be through the AppGate client, through the tunneling, through the gateway into that site. So that's fine. We don't have to do anything more here. IAM role is none, and the default settings can be kept here. So adding new storage, that's totally fine. We have the basic settings here, the default settings. Now here, actually the tagging becomes to be the heart of our name resolving here. So the name resolver will utilize tag names to actually verify what the IP address is of these candidate names that has to be resolved. So for that purpose, we will have some kind of a naming scheme here. And in our example here, we're going to use something called employee app. So we would like to tag all the appliances or all the services inside the protected area with a dedicated name. And we call that for app type, which will signify what kind of app it is. And since we're going to resolve all employee apps in the AppGate name resolver, we're going to tag it as employee app. This will allow us to automate actually the instance IP address resolving. Remember that the IP addresses will be used to configure the access right at the end when a client is connected to it. So let's keep that as employee app and go further for the configuration of the security group. Here we create a new security group and we call it Gate Protected Resources. We actually want to assure that nothing from the outside will be allowed to access it. So we're going to change this and call it all TCP. And who is actually allowed to communicate to this instance? And this is, in our case, only the gateway, so the appliance, the AppGate appliance, which means we would add the IP address here. And this was 168, I believe. Let's have a check here in EC2. So if you look at the AppGate server instance here, we can figure the IP address, this 168, so 10.10.10.168. That's fine, so let's go back to our configuration, so 10.10.10.168, and we have to choose a host. See here, that's it. So we allow all TCP connections from that IP address, right? We also will add another rule for ICMP. This would just simplify us if there should be any debugging or trying to figure out if that appliance is up. So this is the same setting here. 168/32. And let's just use that as the description as well. Keeping consistent. So that looks fine. So now we really are sure that nothing from the outside, from a public IP address, can reach it. So let's review this. This seems to be all fine, and launch it. Remember the key pair. We don't really need it, but still, you'll be able to download that assigned to it. So to do that. And while this is launching, let's have just a review actually what we're going to do next now to access this resource from the AppGate system. We have something called the entitlement. As you see here in the graph, the entitlement is the definition of the resource to be accessed, and these attributes that we are defining here is protocol and port, such as an IP address usually, and a port number, and a protocol type as TCP, for example. And we actually don't going to use that IP address since we're going to use a name resolution. So we're going to do that different. But an entitlement has also something attached to it, which is a condition, which will always be executed or evaluated at access time. The entitlement has been put into a policy. A policy can be seen as a grouping or the case that you want to establish a use case, organizational level or functional level. So policy is grouping entitlements. A filter then will determine what user will utilize this policy or is allowed to use this policy. So from that perspective, a user is usually coming from an identity source regarding the identification you're doing it. So somewhere that is mapped, and that's a filter. So looking at the way actually we're going to implement this, you see that we have a resource, the Tomcat server, which is launching in the background, and we're going to use the AWS tag that we provided to this instance before. So we tagged it with something, a name called app type, and the value employee app. So our system will use that value in the entitlement to resolve them to IP addresses. As you can see also, we will create a policy which will map the AWS employee app to it, but also a filter which then will allow us to automatically enable for a certain user this policy. A condition we actually won't use today is just always true, so that means that there's no other restriction attached to it. Now we're going to create the first entitlement to access the resource. So go on entitlement, click on new entitlement, and give it a name. So here we just give it a name and say that employee server. Select the site. Remember, this was AWS Frankfurt site, it's only one. An action, in our case, we just want to allow TCP protocol up, port 80, and the host you want to access. Now, since we don't really want to use IP addresses, and we want to use name resolving, dynamically done, so we're going to use this syntax, AWS :// and as you see, it's already typed in here, and it's called tag :app type. So this is a naming convention or syntax, which means that we're going to resolve all the hosts inside this VPC that is actually tagged with a tag called app type and looking for the value employee app. So this is actually essentially how at the end the IP address will be resolved. As with the conditions, we skip that. We don't need any extra condition here. Save changes. All right. So let's create a user. We need to have a user which actually going to be our test user accessing these resources. So let's go to configurations. And then we have a menu entry called identity providers. At the moment, we only have the local database available. Of course, you could add another identity provider, say LDAP or SAML, but for the moment, this is fine. So we click on Actions here and say Manage Local Users. Let's add a new user. Let's give it a username. We call that person, for example, Mike. And Mike is just a username. So Mike has a password. And Mike has also a first name and last name. Password. We always have to give an email. We don't need to give a phone number, but one important fact here is that we want to be able to automatically map these two policies inside the filters through filter policy. We tag this person as an employee. So this will allow us to dynamically create this, actually what's possible for that user when accessing the system. So next step is to create actually a filter. And as we told before, actually a filter is an important mechanism here, which will map users to policies. So if you create a new filter, you always have to decide actually what are you looking for, how to select the user. So let's try that. So create a new filter. We call it employee filter, since we're going to try to filter all the employees into that mapping. We then can choose a kind of a test that has to pass. So if any of these is true, then that's totally fine. And as we saw in the previous step, we have actually tagged that Mike as part of an employee. So we tag tagged it with employee. So let's use that for actually being able to get in automatic mapping. So we say that if any of the following is true, then the field will pass. So if a tag contains the value employee, this one will pass. I will just add another tag here to signify this is an employee filter. Save the changes. So now what we're doing is kind of gluing everything together. So for that reason, we start creating a new policy. We call it employee policy, since we want to collect all the resources to be accessible in a policy called employee. Now we map the filter, which we're going to call called employee, to it. So that we glue now together the filtering of the users to that policy. But we have also to say what entitlement we want to give. So you can either enter that by name or by tag. So let's try that with by tag. We tagged here the entitlement as employee. Let's bring that up. And that's fine for the moment. We actually don't need to put that in the tag, but we can add here employee for consistency. So this is aligned with the employee use case here. So now we're actually all set to start testing the client. This is now getting to our last step, and the interesting part here to test actually what we have done also works. So first of all, we're going to install the client, and then we're going to log in as Mike and see that we can access this Tomcat resource, which is only at the moment possible to access through the AppGate system. You can download the client from the host, actually, from the AppGate system. You have simply to type clients, CRI, and look at the list of installers to download. So you can either have the OS X installer or the Windows installer, but you can always go through the AppGate Download Center on the www.cryptzone.com download center/appgate, where you find the downloads for the different operating systems. So let's try to fetch it from the instance here and install it. After installing the client, we want to verify that all the things work together. As you can see here from my AWS console, the IP of the resource, the Tomcat server, is only internally available on 10.10.10.77. There is no external IP address available to access it. So what we have to do now is to start the client and actually log in as Mike the employee. So here we have already started the client. On macOS, it is residing on the top. So let me just enter this host name here, which is not that beautiful, but it makes its test purpose very good. So let's contact it through clicking on next. As you see, we actually are asked to verify the validity of this certificate. We click, of course, that we have verified it, and next. So now, we actually can choose to enter some valid credentials. So we choose identity provider local. There's no other identity provider set up, and we're going to give Mike a chance to log in. So Mike, the password, as we said before. As you can see, Mike is connected successfully to one site. Perfect. So let's see if we can access now this service. 10.10.10.77. And as you can see, we have actually succeeded. So this means now we have a tunnel from the client, from my machine, through the AppGate client, is an encrypted TLSN tunnel, talking to the AppGate server, so-called the gateway, exciting the gateway into the site exactly for that purpose to this instance on the 10.10.10.77 instance. So that was pretty cool. I think we have succeeded to access a protected resource with AppGate system. So we have done certain things here which are key, I would say. And first of all, that we can resolve a IP address of an instance or many IP addresses or a whole farm of IP addresses via tagging or naming convention. This is very important to know. So this gives us a flexibility, or let's say a dynamic way to resolve IP addresses in a cloud environment such as AWS. Also, we have created a way how we can filter users and map them to policies. And as we set it up, we tagged the user, and we created a filter for tagging as well the policy and statements. So this is very useful, where we actually can build up an environment that is capable of adapting to changing user force and adapting to context where the user resides and so forth, but as well to server environments where servers might spin up or spin down. So this was only the top of the iceberg, but actually it works. So there are many steps that you could try things out and actually play with it. Since this is available on AWS, you should be able to work with tags, or should be familiar with tags, and try this out by expanding on that. You can also try to, for example, an ICMP entitlement to enable ping on the resource. It's just about to try it out and have fun. So thank you for listening. There are some more resources available. You can access these through our actually AppGate community on cryptzonerebulletin.net. The product documentation is available on our help center, but also on our main site for AWS.